Good day, grade 9s. How are you guys doing? Welcome to yet another physical science lesson. I think this is the first recording I've done for you guys. After you get to go back home, today we're continuing with this concept of pressure, but now we are moving on to, we want to explain why objects float and why they sink, and then also look at the concept and the idea of something called upthrust, right? Upthrust. We have to see how upthrust affects why an object is able to float. Okay, so lesson 24, these are objectives. May you please just have a look at the objectives. You can also just look at the last lesson that we did, where we looked at density and how it affects whether an object is going to float or sink in a particular liquid. So you can just also quickly look at that before you get into this one. Okay? Right, so we say that floating occurs when you have substances that are being placed in a liquid. Alright? And for any of these substances, we would say that if the upthrust, which I will explain in due course, is equal to the weight of the body, then the substance is going to float. So if we have an object, right, and we place that object into the water, right, then that object is going to float dependent on whether the forces that are pushing it up are greater than the forces that are pulling it down. The forces that push it up are referred to as upthrust forces, whereas the force that pushes it down is the weight of that particular object. Okay? So before we go to that, in the previous lesson, I think we looked at how substances like glycerin and skimmed milk, which one would float in water, or depending on which liquid or which substance you were comparing. Here now, we are told about how you have things like ice, a wooden cork, or how they are able to actually float on the water, but when you place them in the water, if you refer to a textbook, right, you see an image of that wooden cork and how it's floating on the water and the depth. If you go to your textbooks, page 133, in your living physics, you see how those two substances or two objects are floating in the water. The ice is almost floating in the water, but it's almost submerged, whereas the cork floats much higher in the water, right? And this is now dependent on the density of the object. The cork is much less dense than the ice. So what happens is that the cork will actually float, and a bigger part of the cork will be above the water. Whereas the ice, because the density of the ice is almost similar to that of the water, the ice is almost completely submerged in the water, but it does not sink in the water, right? So you can just read up, you just read, I'm explaining this part of the notes. You can just read up on that, and what you can do is you can pause the video, read first, and then listen to what I already explained, and then you can also rewind. Okay, so I'll pause just a bit, just to give you enough time to just read up on that. Okay, so giving the example of the ice, we wrote here how icebergs float in water. However, a much bigger part of the iceberg would actually be below the water. Or if you're on a cruise ship, right? If you've ever been on a cruise ship, or if you've ever been to the ocean and you've ever been on a very big boat, and then you are moving in the ocean, or even if you've watched it in a movie. Myself, I watched it like on this movie, the movie called The Titanic, right? So as the boat is moving, the people who are on the boat or who are on the ship, when they see icebergs, they can only see the top of the iceberg. So when you see the top of the iceberg, you just think, oh, it's just a small bit of ice. But under the water, there would actually be a gigantic, a very, very big block of ice that will be down there. So if you actually hit it, right, if the captain of the ship isn't able to pick it up on the radar that there is a massive iceberg coming up, then you can even lead to the ship sinking, which is what happened with the Titanic. They didn't see the iceberg soon enough. They just thought, okay, it's just a lot of ice that's on the water, but there was a big piece of ice which was below the water. This goes on to explain the idea of floating depth, that something will be floating in the water, but a bigger part of it will be below the water. Okay? Then we have this idea, this question, but before we move to this one, let me just play something here.
What determines
right? So, when we talked about pressure, if you recall, we talked about how effectively pressure varies with depth. And the deeper you go, the more pressure there is, right? And the substance, like the chicken is going to float, but a wooden or maybe a solid block is going to sink, right? A solid block is going to sink. And what happens exactly in this case is that as the object sinks, right, what we have here is the surrounding water molecules colliding, but they are forcing up, they are pushing up the block which you have dropped into the water. So if you drop a block into the water, there are going to be particles that are going to be acting under it, pushing it up, saying, please don't come down. But the weight of the water which is on top of it is effectively going to be pushing it down. So you always have two forces acting, right? Weight of the water above there, the weight of the water above is pushing the object down, right? The weight of the water will be pushing the object down. However, you have the upthrust, which again, I'll say it again, I'm going to explain it just now. The upthrust will be pushing the block upwards. So as the block is sinking into the water, the weight, because as it goes down, more water is now on top of it. So now it's actually feeling a greater pressure. That's why we say if you go and you dive into the pool, if you dive into a pool, you will find that the deeper you go into the pool, the more pressure you are going to feel. Okay? The more pressure you're going to feel. And pressure will increase due to the weight of the object, due to the mass actually on top of the object, right? So you also find that the density of a liquid, we talked about the density of a liquid, and we say that if an object is denser than the liquid which you drop it into, that object, will it sink or will it float? If the object is denser than the liquid, will the object sink or float? So you can just pause the video for a few seconds and ask yourself if the object will sink or float. Okay, so you find that if the object is denser than the liquid, the object will sink. The object will sink to the bottom of the water. That's what will happen there. Okay, so having said that now, we would ask the question to say, but why don't boats sink when they're in the sea? Because I'm sure you've seen boats before. They are massive, they're extremely big, and they are made up of steel. So you would assume that the steel would have to sink if you place it in water. But we've seen that boats don't sink. And if you can just read, I tried to explain it as best as I could here, to say that when you see that big boat, the hull of the ship, right, if you see the big boat, it always is like it has this belly, this big stomach that it has under it, right? So even if you see the cruise ships or whatever type of ships you've seen, there is always that big bottom part, right, where there is effectively, I won't say nothing, right, but there's a lot of empty spaces at the bottom of the ship, and then people are like at the top layer or top level of the ship, and then it starts going up, I just keep having this image of a cruise ship. I hope you guys have seen a cruise ship. Let me just see if I can find you a cruise ship just now. Okay, so yeah, I just googled cruise ship. I think even wherever you are, you could have also googled cruise ship. And yeah, that's what a cruise ship looks like. And if you go for a cruise and you're going to wherever it is you're going, maybe you'll be going to Haiti or to the Caribbean or Spain or wherever it is you'll be going, right? People can be on these cruise ships and they can be on the cruise ship for weeks, for months, depending on how much cash you have, right? But just look at how massive that thing is. And it doesn't sink. And it's made of steel. Don't think that it's made of plastic or wood. It's made of steel. But then you'll find that at its base, at the bottom of the cruise ship, there is a lot of empty space that is there. Okay? There's a lot of empty space that is there. So with sinks, the hull of the ship, right? The hull of the ship, the hull will be at the bottom of the ship, right? Some of it may even be slightly below the layer, what's it called? The part of the water. We can't even see some of it, but some of it is even under. Some of it is even under the water. Okay? Some of it is even under the water. So the hull of the ship is full of air. And because the hull of the ship is full of air, it means that it increases the volume. It has massive volume. If you're going to calculate the density, remember when you calculate density, we say mass over volume. So what you're going to do is you're going to say the mass of the ship, right, divided by the volume of the ship. So all of the empty air spaces that are in the hull of the ship, they constitute the volume. So if you then say the mass of the ship divided by the volume, and you find that your value is less than 1 gram per cubic centimeter, remember that's the density of water, all right? So if your density of that ship is less than the density of the water on which it is floating on, that ship is going to float. It's not going to sink. That's why boats don't sink, right? I would encourage you to ask any questions, any follow-up questions if you have difficulties understanding it. Okay, so also before we proceed, I just let it, since we have the internet, that's what an iceberg looks like, okay? That's what an iceberg looks like. If you are in the ocean and you are on a boat, the only thing you can see is the top of the iceberg. But a much bigger part, which is where we say 90% of the iceberg is actually below the water. Okay? 90% of the iceberg is actually below the water. So if you are in a big ship, you just look at this thing and you think, oh, it's so small, we can just pass over it and break it with our massive ship. But then effectively when you bump into it, it's even much bigger and it will end up cracking your ship and you find yourself sinking. You find yourself sinking. Okay? I hope we have understood that concept. Right, so now let's look at what I've been saying, upthrust forces since the beginning of the lesson. And upthrust forces, effectively we say, when you have an object, let's say any object, you take a rock, you drop it into the water, you take a piece of food, you drop it into the water. Whatever object that you're going to drop into the water, two forces are going to act on that object. There are two forces that are going to act on that object. So please just read up on whatever is on the screen before I start explaining these things. Just read up, just read up.
The next thing we need to look at is why some objects float while others sink. And for this, we need to understand upthrust. Let's imagine that we have a box that's submerged in water. Due to the collisions of all the tiny water molecules around the box, the surrounding water will exert forces on the box from all directions. Because the bottom of the box is deeper than the top though, the box will experience a larger upwards force from the bottom than it will a downwards force from the top. This means that overall there'll be a resultant force upwards, which pushes the box up. And it's this upwards force that we refer to as the upthrust. If that was the whole story, then everything would float, as all submerged items have upthrust. Importantly though, there's also the object's weight to consider, as that acts downwards, and so pulls the object down. So really, it's all about whether the upthrust or the weight is larger.
Okay, so that's basically it. If the upward force that is pushing the box upwards, they are always, like you've seen, there's a force exerted by the liquid that is pushing the box upwards. If that force is greater than the weight of the water, which is pushing the object downwards, right? The weight of the object itself. So if you drop a rock, a big stone into the water, the weight of the stone or the rock is going to be heavier than that of the water. Okay? The weight of the rock is going to be heavier than that of the water, and it's going to be heavier and it's going to be bigger than the force of the forces acting or pushing the rock upwards. So the rock is going to sink. Okay? So you will see that, however, if the object has a great volume, if the object has a greater volume, okay, so let's say you drop a ball, a football, right? A football has a lot of air inside of it, so it has a greater volume than mass. So when you drop it onto the water, that's why the football doesn't sink, it just floats, because it has a greater volume, right? And because it has a greater volume, it has a greater upthrust. Okay? Another thing that we consider is this. If we were to have the density of the liquid, if we were to drop something into a liquid that is, which word did I say it, viscous, right? If we drop into a very thick liquid, okay, then again the object will not sink, because the greater the density of the liquid, then the greater the upthrust. Then the greater the what? The upthrust. So all of this now is known as Archimedes' principle, right? It's known as Archimedes' principle. I think what you guys would have to do also is just to Google Archimedes, and he was a Greek philosopher, a Greek scientist who was there a very long time ago, and he discovered that, oh, okay, if you go into a pool or if you go into a body of water, then that body of water, if you go into your bathtub right now, if you have a bathtub, I hope you have a bathtub, or if you have a bowl or a basin, I don't know what you bath inside of, but if you go and you step into it, or you go and you sit into in the bathtub, the moment you go in, you're going to displace some water, right? You're going to move the water upwards, right, as your body goes downwards, right? And there's a wonderful concept that is there. You see the word eureka, and then he explained it very well. But for our purposes, Archimedes' principle says that the upthrust force on a body immersed in a liquid is equal to the weight of the water or of the liquid displaced by the body, right? This should read, the upthrust force on a body immersed in a liquid is equal to the weight, right, of the liquid displaced by the body. So if you go into a body of water, right, and you have a mass or you have a weight of, let's say 400 newtons, the amount of water that you're going to displace is also going to be equal to 400 newtons, right? It's pretty simple. But I hope we have managed to grasp the main concept that we wanted to deal with here, that objects float because their upthrust force, the force that is pushing up the object, is greater than the weight of the object, which is forcing it downwards. And we know that the greater the volume of an object, so if an object has more volume, the upthrust is going to be more. If the liquid in which you place the object is dense, then the upthrust is also going to be more. Okay? So guys, please, I know you guys are having so much energy, so I hope you watch this video, and I will discuss immediately after you finish watching the video. This is Marshall A.C. Candiado. Goodbye.